Hey everyone, so we've talked about power rule, we've done chain rule, quotient rule, product rule, we've talked about combining all these rules. So now we need to move forward into rules for finding derivatives of trigonometric functions. So these are ones, you guys, these 6 are just ones that you have to memorize, all right? So the derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. Derivative of tangent is secant squared of x, which, just as a reminder, you guys, that means secant of x times secant of x, or we could call it secant of x quantity squared. All right, but usually we write the 2 after the secant and then we write the x. But that's what that means, just as a refresher from trig. The derivative of cosecant of x is negative cosecant x cotangent x. The derivative of secant is secant of x tangent of x. And the derivative of cotangent is negative cosecant squared x. Again, cosecant squared x just means the cosecant of x squared. Okay? So let's actually look at some examples here. So find the derivatives of the following functions. So we've got f of x equals sine x plus cosine x. So f prime of x is going to equal, the derivative of sine is cosine of x, and the derivative of cosine of x is negative sine of x. That's it. As long as you know the rules, it's super easy. Derivative of 3 tangent of x. So the 3 is just a constant in front, it's going to stay out front. The derivative of tangent is secant squared x. For number 3, we've got 2 cosecant x plus 4 secant x. So the derivative of 2 cosecant x would be negative 2 cosecant x cotangent x. And then we've got plus 4 times the derivative of secant, which is secant x tangent x. And for number 4, f prime is going to equal, let's see, the derivative of cotangent is negative cosecant, so negative 3 cosecant squared x plus 5 secant squared x, because the derivative of tangent is secant squared. Okay, those were super basic, super straightforward. Now we have to look at some that actually involve some more things. So product rule, quotient rule, that kind of thing. We're going to deal with chain rule on a different day. So when we look here, we've got x squared times the sine of x. So we know right here that this is going to require product rule. So if I'm going to do product rule, let's see, I get y prime equals, we're going to take the derivative of the second function. So the derivative of sine is cosine of x, and we're going to multiply by the first function, so x squared, plus the derivative of the first function, which is 2x, that's just normal power rule, times the second function, which is sine of x. It doesn't matter what order you write this. If you took the derivative first of x squared, that's fine. You'd have this flip-flopped. If we're multiplying, it doesn't matter. I am, however, going to rewrite at least this x squared so that it's in front of the cosine of x, just because to me it looks better. So it's x squared times cosine x plus 2x sine x. And there's our derivative there. For number 6, we've got some quotient rule going on. So we know quotient rule is the low d high minus high d low all over low squared. So u prime is equal to, the low is 1 minus sine x. The derivative of the top is going to be negative sine x minus the top, which is cosine x, times the derivative of the bottom. So the derivative of 1 minus sine x. Well, the derivative of 1 is 0. The derivative of negative sine x would be negative cosine x all over low squared. So 1 minus sine x quantity squared. Now we can do some simplifying here. You're going to need to remember some trig rules. So if I distribute this negative sine x, let's see, I'd have negative sine x plus sine squared x, and then this is plus cosine squared x, all over 1 minus sine x quantity squared. And hopefully, when you guys look at sine squared x plus cosine squared x, you can remember that that equals 1. That's one of your Pythagorean identities from trig. So we have 1 minus sine x on the top, and we have 1 minus sine x quantity squared on the bottom. And so when we simplify this down, we end up getting u prime is equal to 1 over 1 minus sine x, because one of those will cancel. So this is our final answer for number 6. So you do need to kind of remember some trig stuff also and be able to simplify with your trig functions. All right, number 7 is another product rule. So f prime of x is going to equal, let's see, we want to do the derivative of the second function. So we're going to leave the first one alone, right? Yeah, that's what I want to do. Leave the first one alone, so that's secant x, times the derivative of tangent, which we know is secant squared x. And then plus, now we're going to leave the second one alone, so tangent x, and we're going to take the derivative of secant of x, which is secant x tangent x. And we're going to simplify that a little bit. So f prime of x is going to equal, let's see, that's secant cubed x plus tangent squared times secant. Again, for product rule, it doesn't matter what order we write these things in because it's all multiplication and addition here, so it doesn't matter the order. All right, we're going to skip number 8 for right now because we're going to jump actually to number 9, which is also a quotient rule. So we're going to do that one instead, and we'll look at number 8 in class if we've got questions. So number 9 is a quotient rule. So f prime of x is going to equal low, which is 2x, d high, so the derivative of secant x minus 1 is secant x tangent x. So low d high minus high, which is secant x minus 1, d low, so the derivative of 2x is 2, all over low squared, which is 2x quantity squared. So then if we start to simplify, let's see, this would be 2x secant x tangent x minus 2 secant x minus 2. So all I did was distribute this 2 inside, right? Oops, that'd be a plus 2. Because really, I could rewrite this 2 in front here and then distribute the 2 inside. All over 2x quantity squared would be 4x squared. And if I look, all of those things are even, so I'm going to simplify. I'm going to take out a 2. So I have x secant x tangent x minus secant x plus 1 all over 2x squared. All right, and then we have another quotient rule right here, which again we can talk about in class if we want to do another one together before you guys start your practice. 11 and 12 are super straightforward. They're just adding and subtracting some things. So derivative of 3x is 3. And then we're going to have plus 2 sine x, oops, sine x, not just x, there we go. And then minus 4 cosecant squared of x. This one is super straightforward. Same with number 12, also super straightforward. Derivative of negative 5 cosecant x is positive 5 cosecant x cotangent x plus derivative of 4 tangent would be 4 secant squared x. All right, so you have to know these rules. It makes everything much, much easier. Now we need to look at a couple more examples real fast. So if you look, number 13 gives you y equals the secant of x, but it asks you to find y double prime. All this means is find the second derivative. So we haven't really talked about that, but really all that means is take the first derivative and then take the derivative again, and that's the second derivative. It's not that hard. So let's take the first derivative. So y prime means what's the derivative of secant of x? And it's secant x times tangent x. So that's nice and easy. Now if I want to do the second derivative, I need to take the derivative of this function here, which I can see requires product rule. So y double prime is going to equal, I'm going to leave the tangent x alone, and I'm going to take the derivative, let's use some colors here. I'm going to take the derivative of secant of x, which is secant x tangent x. And then I'm going to do plus, let's see, now I'm going to leave the secant x alone. So I'm going to leave that first function alone. And I'm going to multiply by the derivative of tangent, which is secant squared of x. And so now when I write my final answer, I get y double prime is equal to, let's see, that's tangent squared x times secant x plus secant cubed x. So that one wasn't too bad. Let's look at number 14. That gets a little bit more involved because we can see that just taking the first derivative already requires product rule, which means taking the second derivative is going to get messy. All right? So let's see here. Y equals 2 sine x times cosine x. So the first thing I'm going to do actually is I'm going to call this my first function, this 2 sine x, and I'm going to call this cosine x my second function. So when I start to take my first derivative, I'm going to leave the second one alone. So I'm just going to bring down cosine of x. And now I want to do the derivative of 2 sine x. Well, I know the derivative of 2 sine x is 2 cosine x. And then I'm going to need a plus sign. Now I'm going to leave the 2 sine x alone. And I need the derivative of cosine of x, which is negative sine of x. So what this is right here is just the first derivative. So let's see, I'm going to simplify this. This is going to be 2 cosine squared of x, and then minus, let's see, 2 sine squared of x. Now we haven't talked about chain rule yet, so I lied and I'm going to rewrite this again. It's 2 cosine x times cosine x minus 2 sine x times sine x, because we're going to need to do some product rule in here. And then I'll show you why chain rule is so helpful later. All right, so let's do the second derivative now. So for y double prime, let's see, I'm going to call this my first function here, and I'm going to call this my second function. And then if you notice, I'm going to need to do product rule over here also. So I'm going to need some more colors. I'm going to call this my first function, and then I'll call the sine of x my second function. All right, let's see if we can do this. Ready? So leave the second one alone, so that's going to be cosine of x, and then take the derivative of 2 cosine x, which is negative 2 sine x. I forgot my equal sign, sorry. Plus, let's see, now I need to leave the first one alone. So 2 cosine x, and then times the derivative of cosine, which is negative sine x. So keep in mind, these two pieces that I just wrote right here are only the derivative of this first part of my function. Now I need to do the derivative of the second part. So I'm going to need a minus sign, and I'm going to put a big set of brackets so that we can do our product rule inside there. So I'm going to leave my sine function alone, so sine x times the derivative of 2 sine is 2 cosine, plus, let's see, I'm going to leave the 2 sine x alone, and I'm going to multiply by the derivative of sine, which is cosine. All right, now I need to simplify. So again, everything inside these brackets is the derivative of this second portion. Everything over here in blue and orange is the derivative of this first part of the function. So now let's actually go ahead and simplify. So y double prime is going to equal, let's see, this is negative 2 sine x cosine x. This is also negative 2 sine x cosine x, because the order doesn't matter when I'm multiplying, so stick with me there. All right, let's see, then this is going to be also a minus 2 sine x cosine x. And then when I distribute this negative, this is also minus 2 sine x cosine x. So really, what is that? 2, 4, 6, 8. Negative 8 sine x cosine x is my second derivative. And I will show you guys actually later when we start doing some chain rule how we could actually find that much easier. It's why chain rule is so effective and so helpful. But hopefully y'all are good and followed along. We will do some practice when I see you in class on Friday. Bye!